Hello everyone, so in this video let us talk about the Leetcode weekly contest 311, the first three problems. I also make a video for the next problem, so stay tuned on this channel. The first problem is smallest even multiple. So the problem statement goes like this, that you're given a positive integer n, return the smallest positive integer that is a multiple of both 2 as well as n. So you're given a number n and you have to just tell that what is the closest next multiple, a number that is a multiple of n as well as 2. So it's very simple, the constraints are very small. What you can do is that 2 means that it is an even number. So what you can directly do is that you can find out all the multiples of n, and whatever is the first multiple of n that is an even number, that's the answer. So how you can get a multiple of n? You can just do a, like, let's say a while loop or or a for loop, whatever you want, till a very large number, let's say like 1000, 2000, whatever you want. And then what you can do is that till that number, whatever first number that comes out to be an even number, that's the overall solution. So I'll go down to the solution part. What you can actually do is that I have done a while loop. It is a never ending while loop, but still it will end as we hit an even number. So what I'll do is that it is a multiple of n. So if the current number, that is n, is multiple of like 2, which means that it is an even number, we return the number that we have, else we'll go to the next multiple. So how we can go to the next multiple? If we have a number, we will keep on adding n. So it's like a multiplication of n into 1, n into 2. That's why we're adding n into n plus 1, or n plus equal to n, which means that we're finding out the next multiple of n. Next multiple means that it has again added n. So again I added n. So we keep on adding n so that we get the next multiple of n. So we are iterating over the multiples of n, and what is the first multiple of n that is also multiple of 2? That's the answer. And just return that. It will not get into the situation we have written just to like make this summarize this whole function, but still it will return from this part only. That's the first problem. The second problem is length of the longest alphabetical contiguous substring. So you're given an alphabetical contiguous substring in a string consisting of consecutive letters in the alphabet. In other words, if any substring of the string this. So what you are trying to say here is that you are given a string s consisting of lowercase letters only. Return the length of the longest alphabetical continuous substring. So you are given a continuous alphabetical substring. This is a continuous alphabetical order. Okay, A, B, C, D till Z. Now, if you take out any substring of this particular segment, and if it is find out in S, that is the longest continuous segment you find out. Okay, you just have to find out in this particular string what is the continuous segment of characters that you can find out. Okay, so what you can do is see that even if the constraints are high, the string I want to match with is very small. It is of 26 characters only. So max of 26 characters match will always be there because it's a very small string that we have compared to. So we will do this in a very brute force way only. And what we'll do is that let's say that we have this string AB, AC, ABA. So AB, AC, ABA. Now what we'll do is that starting from this thing, let's say I want to make a continuous substring starting from this particular A. So starting from this particular A, I have to make the string like this: A, B, C, D, and so on. Okay, so what I'll do is let's say if I want to make a continuous substring starting from this B, so it will start from B, C, D, and so on. I hope you get the point, because it should be continuous segment. So what I'll do is that starting from every segment, I will just check that what is the maximum length of continuous segment I can get from the string A, B, C, D, E, F till Z. Okay, and whatever is the maximum starting for every segment, whatever I got, I'll just print it out. That's the overall solution. Nothing much complicated here as well. So what we have done is we have making and find out the maximum for every position starting from string S. I will just start to match out that for the current character I. So let's say I am on the I starting point. What is the maximum match I can get in the string S? So I will return this function S match, and it will return that if I start from the current character I, what is the maximum like the maximum match I can get, and this is returned from this match function. I will just want to maximize it over all the i's from the string because I want to start from every particular I and return the maximum value. Now what this function will do, that is the string that I want to match to. Then I want to start from this index and I want to iterate over this string S. So maximum contiguous string I want to match is starting from 0, like there is no match. Then because I want to start from the very first, that is the start point, so I want to check that what is the current character that I'm on, because let's say I'm the character let's say X. So I want to start matching from X till X, Y, and Z. Okay, so I want to start from X, so I will just get what is the index I want to start matching with. Then I iterate from the start I want to start with in this match function till the very end of the string. And if the ith character in the string matches with this string jth character, this jth character will start from where I want to match with. So let's say this string I want to match with starts from, let's say, C. So I want to start from this string also from C. So C, D, E, I want to start matching. So if they completely match out, I increment my answer and J also. Okay, which means that if J also increases, because I want to now match the next character. So this J is iterating over this string, this I is iterating over this S string. So both are currently matching out. If they keep on matching out, this answer will increase and J will increase. And whenever they break out, I will just maximize the answer over this and just print out. Okay, so that is the overall thing that I want to just maximize. I can written down this as well in this part, but this makes it more clean. So that's why I've written this in the other function. That is the second problem. You can pause this video and check out the code as well for the second problem as well. The third problem is reverse odd levels of binary tree. So you're given a root of a perfect binary tree, then you have to reverse the node values at each odd level of the tree. So you are seeing that this is a binary tree, a perfect binary tree. Then for odd level, so let's say this is the 0th level, this is the 1th level, so odd. So you have to reverse all the, let's say, nodes at this particular level. So this are reversed, so this has become 5 and this become 3. Let's say this is the even node and this is the odd node which has these values. So you have to reverse all the values. Okay, all the nodes values, because it's a perfect binary tree. Every node will be having like both the child nodes. So or else it will have no other nodes, so it will be reversed. Okay, and you just have to print it out. Now the very simple technique for this is, because I want to travel in a level order traversal, I have to do a level order traversal on this particular node or this particular tree, sorry. And for a particular node, I will store out all the node values which I've iterated over if I am on a odd level. Okay, and then I will just reverse out all the values in this particular node, like all the level, and then I'll just move down to the next level and I will only reverse the values of the odd levels. And that's a very simple technique here as well, nothing much. It's just a level order traversal over this tree. Now a level order traversal is done using BFS technique. BFS is breadth first technique, in which we use a queue. So we'll first take this queue value and just insert all the other nodes which are on below of this node and just put it inside the queue, and then keep on doing that until we'll go to the end. I have a video on level order traversal as well, so I will link out in the I button, so you can check out that video as well. Moving on to the code, so what we have done is that we have created a queue for level order traversal and just push the very first node inside the queue, and we will keep on doing this while loop until the queue becomes empty. Now let's say we have this queue is holding out, and at any current state the current node inside a level. So we have the first node, that is the first level. Then what I'll do is that until the node is empty, what I'll do is that I'll pop out the top node. This level nodes stores out all the nodes in the particular level. Okay, and because I'm iterating over a new level, I'll just clear it out. And then what I'll do is that for a particular level, I have to iterate over all the nodes inside that level. So I'll iterate over all the nodes inside that level like this and pop out from the queue. And then I will also push that node inside this level nodes vector, which is storing out the current level nodes. Okay, now if it has in a left node and the right node, so I'll just push that inside the queue, which is just a standard but BFS technique or a level order technique. This is done. Now the main part come here, that if it is an odd level inside the tree, so if it is an odd level, what I'll do is that I have to swap the values of all these nodes stored in level nodes. So I have to reverse out. So what I'll do is that I have to reverse out. So what I'll do is I'll move to the very half and reverse the first value to the last value, the second value, the second last value, and the third last value. So I have to swap the values only of the level nodes, because the level node is storing out the node at the particular level at the odd level. So I will just swap out these values, but the first with the last, second last with the second, and just swapping out all those values till the very half. This will only swap out these values, and when I've iterated over a particular value, like a particular level, I'll just move down to the next level, increase my level, and just keep on doing that until we have iterated over each and every level. So this is just that we have to iterate over every level. So I'll just get a particular level, insert all the nodes of the next level inside the queue, and just before starting I have to check that how many nodes I have inside this particular queue for the next level. Iterate over all these nodes only, and just print out the particular new tree that we have converted by swapping out the odd level node values. Pretty much simple. You can pause out this video and see the code by your own as well. You can try out the code by your own as well. It's not too much difficult. We have gone through much difficult questions earlier as well. So that's the overall code and the logic for the third problem as well from this particular contest. If you still have any doubts, you can mention down in the comment box of this particular video. Thank you for watching the video till the end. I will see you in the next one. Like coding, and bye.